Wait, you see the slides, right?
Yeah.
Okay. What happens when I do this? What do you see?
Still the slides.
You don't see the.
I'll show you here. Okay, now it's there.
Okay, it just takes a second. Okay. That's right. All right. I'm gonna go ahead and get started. So this week, we're going over mesh improvement, and there's a couple of different things we're gonna go over. Specifically, we're gonna go over the basic settings, which you guys probably have already seen that menu kind of with last week's simulations or before spring break. And then we're also gonna go into the advanced settings as well as go into adaptive mesh refinement. This week there are a lot of screenshots for the assignments. It's kind of a bigger week for assignments, so we're gonna kind of take it slow and go one by one with that. And then, yeah, I'm gonna when I go over the steps, I'll like show them on Fusion with the slides together at the same time. Also, nobody had any issues like submitting assignments or anything, right? For the week 2 stuff. All good? Okay. Here's the attendance QR code if you want to scan it that way. We'll send it out like normal afterwards as well. All right. So, kind of going back a little bit, going over what a mesh really is, like FEA wise, I guess. The way in which a mesh is basically a way to divide a model, a 3D model specifically, into smaller bodies or elements, as they're called specifically in Fusion. And the goal of this is to be able to run calculations on those specific elements. And the smaller the size of that element, the greater the number, or the smaller the size of the mesh, the greater the number of elements there will be. But this also has a downside of it'll take longer to run the simulation. So we want to be really purposeful with how small we're making our mesh and how small it is in certain areas, such as places that have curves, fillets, or any general areas where there's more of an effect due to the force that you're applying to the model. So yeah, like I said, it's going to take more time because the equations that are going to be solved over those elements are basically going to have to be solved on many more elements when you make them smaller, because they need to cover the entire surface of the model. And because of that, they're going to take more time to be solved. Just right there. So just a little like visualization of that. I'm not sure why that slide looks like that. That's strange. Basically, this slide is just going over the actual. Sorry, it's not clicking through for me. The slide's basically just going over the mesh getting finer and finer, and the actual number that's shown down here gets like exponentially bigger. Like it starts at like 30 seconds, and this final one right here is like 30,000 seconds or something like that. So yeah, it's just something to keep in mind when you guys are actually refining your meshes for your models. So how can the mesh actually be modified in Fusion 360? Well, there's a lot of different settings we're going to go over. The main ones that you guys have probably already seen are the average element size, which can be based either on the model size, which goes from 1 to 10%, or they can be an absolute size, which is usually specified in millimeters. Let me just show you where that is in Fusion. So if we go here, if we go ahead and go here, open that simulation, and in the mesh. Oh my God, I can't see it. Hold on. Yeah. Okay, so you see this now. Okay, cool. I can see it now. All right. Yeah, we're good. So if you go ahead and go here and you hit edit mesh, that little arrow there, or the other way you can do that is if you go up here. Yeah, sorry, just go through here. You can right click the mesh as well, and it lets you like choose and select. So the average element size you can see right here, the model base size from 1 to 10%. And if you go ahead and hit this one right here, absolute size, it's going to be specified in millimeters. Usually in this class, we like to go with the model base size because Fusion basically does it for you, which is really nice. So, and then the advanced settings in that tab there, which I'll go over in 1 second. There's many different ones in there. There's the element order. You can create curved mesh elements, which we always have on for this class. You can change the maximum turn angle for like specific curved sections of your model. You can change the maximum like adjacent mesh size ratio, which I'll go into what that is a little bit, the maximum aspect ratio and the minimum element size. So that's going back here. If you go into your advanced settings, you can see all of that right here. And this week's assignment, you're actually going to have to change the model base size, the absolute size. That's the first step of the assignments. And then the next set is going to be changing the maximum turn angle. And I believe there's one other element you're going to have to change on here. So before we get a little further with what what the advanced elements actually are, a couple of helpful tips for this week, since there's a lot of simulations. When you go to solve these simulations, you can actually set them all up and then solve them all at once, which will save you a lot of time, especially if you don't want to sit around waiting for every single one to run. So how you can do that is once you've set up the simulations and they have the green pre-check, you can go ahead and just go and hit solve, and all of the simulations will pop up that you have in this specific file. So there's a ton on this file because it has all the simulations for the assignment, obviously, but you would just go ahead and you can select all, or you can select specific ones that you want to run, and then just go ahead and hit solve, and it'll just send those and do them all at once and bring them back to you all at once. The other thing we have on here is being able to compare different study results. This is something in the results tab. It's not too pertinent, so we're going to kind of just gloss over it really fast. So some of the more important advanced settings that we're going to have to, or you guys are going to have to like kind of keep in mind and change are the element order, which can be parabolic or linear. This basically is just describing the way that the actual mesh shape is created. They can either be like little triangles, or there's like certain like curved looking triangles. I'm not exactly sure how I would describe that shape. The maximum turn angle on curves basically takes arcs such as this inner face right here, or the outer face, or the inner outer face of the smaller hole, and basically makes the mesh finer at those points, because usually those points on models will have more, the actual force will have more of an effect on what actually happens at that point in the model. And then the maximum adjacent mesh size ratio basically is just a proportion between the adjacent elements. So if you have a mesh with, say, like right here, these tiny, right here, it basically just describes the difference between the one right next to it, or above it, or below it on that surface specifically. So, and then the minimum element size is simply just a percentage of the average size of the actual element. So if you specify, say, 10%, if you want the mesh element to be 10% of the actual model size, this will basically take a percentage of that and specify it as the minimum element size it can have, especially if you're modifying it along curves and things like that. It's good to be able to not have it be too small. Sometimes there can be errors if you don't specify this or set it too low. So it's just something to keep in mind of. We don't really mess with this one as much. If you're supposed to, we will explain it in the actual assignment. And then if you guys ever forget like what specifically which one does, you can actually just go ahead and hover over it. So like for the max turn angles, you see it pop, it gives you a little pop-up of what it specifically is. So now that we've gone over that, we're gonna go ahead and start the first assignment. We're gonna have kind of a little bit of time for you guys to work on that, and then maybe about 20 minutes, we'll say, and then we're gonna go over in to the next assignment, which is basically just changing the actual advanced settings. This is starting with the kind of basic mesh settings that we had seen before. So let us know if you have questions. We'll be around to help. All right, I'm gonna keep going and introduce the next part of the assignment, which is starting to get into the advanced mesh settings. We're gonna I'm just gonna introduce it because obviously it takes time to run these simulations. So if you guys want to set them up and then start running them, we still have adaptive mesh refinement to do. So we're probably gonna take more time from here and then just give more time to at least have them set up and running. So yeah, so we'll go ahead and just do that. Basically for the next part of this assignment, you're just gonna go ahead and change the max turn angle from to 35 and then 10, and then the minimum element size you're gonna do 10% and 5%. And then it's just the normal screenshots from there. Yeah, so the only thing you would go in and change, so like for the max turn here, basically you would just go in and go in here and change this right here. And oh yeah, this slider is really bad. You can't like see like the exact number. So if you hover over it, it'll show you like the exact value you're on, and you can change like mess with it from there. But yeah, but it's the same load case. That's the only thing you're really changing there. Go ahead and keep it on that. Okay, so really quick clarification. When you go and do that study, like the studies for this next part of the assignment, go ahead and keep the model base size at 10%. This is just so that the simulation doesn't take absolutely forever to run. Yeah, thank you for catching that. Yeah, that's it. Okay, I'm gonna keep going forward and talk about adaptive mesh refinement. So for adaptive mesh refinement, just so basically adaptive mesh refinement, what it does. There we go. It's basically an automated tool in Fusion 360 that allows you to like locally change a specific point of the mesh. So like in our model, we have like the interface hole, right? That part has more effects, or the load has more effect on that part than say the flatter region on top. Basically what Fusion does is it identifies that, and with that, it'll go in and make that mesh of the inner hole finer while not touching the mesh of the top part. So basically it's refining the mesh, but only refining the parts it needs to, so that way there isn't extra time being used in that simulation. So like I said, it's important for high stress areas, and it basically subdivides those specific elements in those areas into smaller regions, or just refining the mesh. And it's an iterative process. You can define how long you want this to go on for, and we'll talk about that in a little bit. And you can vary a couple of different parameters doing this. The first one is the maximum number of mesh refinements. That's how you kind of tell it when to stop. There's some presets on Fusion 360 that we'll show you, and then there's also custom ones you can choose. The next one is the results convergence tolerance. And basically this is just saying the percent difference between one result and the next result, like we talked about before, and it just compares those two. And if those are below a certain percentage of difference, it basically stops running the iterative process, and it just goes ahead and then does the actual static stress simulation and gives you the results. The next one is the portion of elements to refine. This is based on off of a percentage basically of the model, and you can define say 30, 40, 50% of the model to actually refine of those specific elements in there. And then another parameter you can vary, which we don't really go into in this class, is the results for baseline accuracy. Basically, you run a simulation with your own mesh defined, and that's kind of the baseline. And then Fusion goes from there and kind of refines it from there. So before we get to those, I'm going to go straight to Fusion and show you guys from Fusion. So there's 4 predefined options, and I'll show you where to get the mesh refinement from. Hold on. So when you have your study open, right, before you even run or do anything, you go ahead and just set up a basic mesh. That's fine. You're going to want to go to manage and then click that drop down. And then here you'll see adaptive mesh refinement. I'm not exactly sure why they don't include this in the mesh settings. It's kind of strange, but it's up here. You can also search for it using like the little Fusion like toolbar. So if you go ahead and click on that, you're going to get this prompt right here. Make sure static stress is selected because that's what we're running. And from here, you get the adaptive mesh refinement prompt. This one is currently set up to none, so there's no adaptive mesh refinement, which is kind of the default as normal. And you can see here kind of the different parameters that we talked about before. And if I change it, you're going to go ahead and see that it changes. So basically for the low compared to the none, it's going to refine the mesh 2 times, and it's going to want the difference between the actual results to be either at 20% or below that, and then it'll stop. It's going to refine 10% of the elements based on the model, and then it's going to base the results of this on the von Mises stress initial kind of mesh from there. And as you can see, if we go to high, it's going to refine it six times, and then the convergence tolerance is going to be much lower, so it's going to want a much more accurate result. So yeah, so these are the 4 kind of presets, and then if you want to do a custom one, you can do a custom one here. That's part of your assignment, which I'll go to in a second. Just gonna go ahead and hit cancel on that for now. So like I said, this slide and the next one kind of go over the different presets and the predefined options there are. That's the none and low there. And then medium and high. So for the assignment for this part, basically you're just going to go ahead and do the 4 predefined options, none, low, medium, and high. And then what we want you guys to do is to actually go in and create your own custom preset. Like I showed with going into that prompt. You go to custom and you change the values yourself right here. And the one thing we ask is that you guys please keep those values that you input between the low and high range. So that way Fusion, one, there's no like errors with it. And also would take significantly longer if you were to say change the number of iterations to like 25. And then please note in your guys' Word document, whenever you're going to submit your assignment, what values you actually used. Because when we go to grade, we may run the simulations and see if they're kind of accurate with what you guys actually put into the into Fusion 360 and the assignment. Yeah. Does anyone have any questions on that right now?